Hey guys, good morning. Happy New Year. Stephen Fleet here. Hey, came up with a interesting little primality test. Normally we think of, let's take the sieve of Eratosthenes, if I'm saying it right. But normally we take a look at, okay, we have a certain number and can it be divided by anything evenly? This is a division table. So you have to ignore these black dots and some of the little doodling I've been doing on, but we'll say, for example, 4 divided by 2 is 2, or 6 divided by 2 is 3. And so if it can't be divided by an integer evenly, there's just nothing that fills it. And so that's your sieve, but there's also a sieve that happens diagonally, in this case to our left. We ignore something divided by 1, so like 7 divided by 1, we would ignore this first line. But let's take a value, for example, 23. You can draw the diagonal through it all the way through and it doesn't hit anything. And ultimately what you end up getting is something like this, where say our prime that we're testing, our prime value is 11. So 11 minus 2 divided by 2, 11 minus 3 divided by 3, 11 minus 4 divided by 4, 11 minus 5 divided by 5. And so on, to where if none of them equal an integer, then it's a prime number. And you can then put those into a product of signs, and then it equals 0 if it's composite, it doesn't equal 0 if it's prime. Now this will, the function itself will probably start like this and then eventually taper off smaller and smaller. You probably have to add a bigger value here, so that way it doesn't get super small that when you code it up, it thinks it is 0. So interesting little test. Not sure if this has been known. I imagine probably it has, but it's pretty cool. All right, thanks.